Let's start him. As part of Kafka administration, first let's understand what is Kafka. So Kafka is a streaming and messaging framework. Kafka is a streaming and messaging framework. It is implemented using Scala language. This software implemented using Scala language, and Scala runs on top of JVMT, Java Virtual Machine. Scala language runs on Java Virtual Machine. So once we compile, once we run Scala application, it runs on Java JVM, Java Virtual Machine, Java Virtual Machine. So Kafka is a software designed based on Scala language. So to run Kafka software, we need JVM, Java Virtual Machine. Okay. So Kafka is what? It's a streaming and messaging framework. And initially it was implemented to communicate Kafka with Hadoop with non-Hadoop systems setting. Hadoop with non-Hadoop systems to integrate Hadoop systems with non-Hadoop systems. But the main advantages of Kafka, people started integrating Java applications with Kafka and Python applications with Kafka and SAP applications with Kafka, .NET applications with Kafka, Spark applications with Kafka. So Kafka using multiple places, multiple applications nowadays using Kafka, because Kafka is a open source and free. Kafka is open source and free. No need to pay single rupee for Kafka software. We can download, we can install. So Kafka software is maintained by Apache community team. Apache maintains all open source and free softwares. So we can download Apache Kafka, we can install Apache Kafka. No need to pay single rupee for Kafka software. This is one important reason most of the people choosing Kafka as a streaming or messaging framework. Okay. Yep. Yep. Now let's understand what is messaging system. Messaging system can be used to exchange messages between two or more persons, two or more applications, or two or more devices. A message, a message, a message, a messaging system can be used to one. Messaging system can be used to exchange messages, exchange messages between two or more persons or applications, two or more persons or applications or devices, two or more applications or persons or devices, etc. So this mechanism we can also call publish and subscribe. This mechanism we can also call publish and subscribe thing. A publish or publish and subscribe. Publish and subscribe. Publish and subscribe messaging system allows to a sender to send or write messages. A publish and subscribe messaging, a publish and subscribe messaging system allows to send or write messages. send or write messages, allows to a sender to send or write messages, and a receiver a receiver can receive messages too. A receiver to read or consume messages. So in messaging system, a sender can send messages, a receiver can receive messages. In Apache Kafka, Kafka, sender is called producer, and subscriber is called sorry team. A receiver is called receiver is called subscriber. Receiver is called consumer team. So in Apache Kafka, sender is called producer, receiver is called consumer team. So consumer consumes or reads data from Kafka, producer writes or produces messages into Kafka. Clear, right team? What is producer and consumer? Producer and consumer, or what is messaging system? In messaging system, we exchange messages between two or more persons or two or more applications or devices. Yet two people are there. One is producers and another people is consumers. Producers writes messages or produces messages into Kafka, and consumers consumes that message or receives that message from Kafka. So there are two types of messaging patterns available. There are two types of messaging patterns. There are two types of messaging patterns available. Messaging patterns available. They are first one, point to point messaging system. Point to point messaging system. Point to point messaging system, and publish subscribe messaging system. Publish and subscribe. Publish and subscribe messaging system. Publish and subscribe messaging system team. Point to point subscribe system. Point to point subscribe. Point to point messaging system, and publish and subscribe messaging system. What is point to point? What is point to point? Point to point messaging system. Now let's understand what is point to point messaging system. What is point to point messaging system? So in this messaging system, messages continue in queue team. So whether you consume or not, more than one consumer can consume the message in the queue. So in this messaging system, messages are continue remain in queue. More than one consumer can consume the messages in this queue, but only one consumer can consume particular message. More than one consumer consume, but one message can consume by one particular message can consume by only one consumer. After the consumer reads the message in queue, the message disappears from the queue team. Once consumer consumes the message from queue, it disappears from the queue. In point-to-point messaging system, messages continues to remain in a queue. Remains in a queue. More than one consumer can consume messages, consume the messages. More than one consumer can consume the messages, but only one consumer can consume a particular message. But only one consumer can consume message stream. One consumer can consume message. Once consumer consumes messages, after one consumer, after the consumer reads the message in the queue, the message disappears from the queue team. The message disappears from the queue. So only one consumer can consume message. Any number of consumers can read that message. Means any consumer can read message from queue, but once consumer consumes that message, the message disappears from the queue team. It will not visible to any other consumers. This is called point-to-point messaging system. Point-to-point messaging system. So once sender sends message, once consumer consumes message disappears from queue. This type of messaging system is point-to-point messaging system too. Next, coming to publish and subscriber. What is publish and subscriber system? What is publish and subscriber system? What is publish and subscriber system? Let's understand what is publish and subscriber system. In this publish and subscribe system team, messages continue to remain in a topic. In point-to-point messaging system, messages continues in queue, but here messages continues in topic team. In this system, messages continues remains in topic. Topic. So in this messaging system thing, in this publish and subscribe messaging system, consumer can take more than one topic thing. A consumer can take more than one topic. More than one topic. More than one topic. Consume every message. Consume every message thing. A consumer can consume every message. So in this publish and subscribe messaging system, a consumer can take more than one topic, and consume every message in the topic, and and can consume every message, every message, every message in the topic. Okay. So clear writing. Yep. Now let's start understanding Kafka architecture. In Kafka architecture, mainly there are some important components. First one, zookeeper. Second one, server or broker. And third one, producer. And fourth one, consumer. Fourth one is consumer too. So these four important components in these are four important components in Kafka architecture. Let's diagrammatically understand it. So in Kafka architecture, there is only one daemon runs in team. There is only one daemon runs called server or broker. In Kafka architecture, there is only one daemon. There is only one daemon runs is called Kafka server or broker. So this one is server or broker. Server or broker too. Only one daemon in Kafka cluster is called server or broker. So we can take any number of server or broker missions too. The only one daemon runs in Kafka called server or broker. We can take any number of servers or brokers. We can take any number of servers or brokers. We can take any number of servers or brokers. Next one thing, next important component after servers or broker, next important component is zookeeper thing. So zookeeper is a coordinator between different components of Kafka. Zookeeper Zookeeper is a coordinator between different components. So next important one, zookeeper thing. Zookeeper Zookeeper is a coordinator between different components, between different different components in Kafka. Zookeeper is a zookeeper is a coordinator between different components in Kafka. There is one more important component is called producer string. Producer. So we can take one producer or multiple producers. We can take one producer or we can take multiple producers too. Producer. So we can take one producer or multiple producers. So producer communicates with zookeeper and understands the Kafka, then writes messages into Kafka. Writes messages into Kafka team. Writes or produces messages into Kafka. Writes or produces messages into Kafka. Then coming to first important point here. Producer is an application. Producer is an application. Producer is a application maybe Java, or maybe Python, or maybe Scala, or any programming application, which supports Kafka, team. So producer is an application. It may be written in Java, it may be written in Python, it may be written in Scala, any programming language which supports Kafka. So what producer will do? Producer application writes messages or produces messages into Kafka. Produces messages into Kafka team. Yeah. Coming to other side, we can take one consumer or we can take multiple consumer. We can take one consumer or we can take multiple consumers. So we can take one consumer or we can take multiple consumers too. So consumer communicates with the zookeeper and gets the information of server or broker. Then consumer consumes messages from Kafka. Consumes or reads messages. Consumes or reads messages too. Consumer consumes or reads messages. So this is Kafka architecture. This is Kafka architecture. Yeah. So next important component is consumer. So what consumer do? Consumer is a application. Is a application may be written in consumer is application may be written in any of the programming language which is supported by Kafka and consumes messages from Kafka team. Consumer consumer application reads or consumes reads messages or consumes messages from Kafka. So practice purpose team practice purpose Apache people given console producer and consumer consumer. So instead of writing programming language techniques for testing purpose only team, this is not for real time implementation. Testing purpose they given console producer and console consumer. Console producer and console consumer team. And next important point to team, developers. Kafka developers team. Kafka developers. Sir. Kafka developers works at developing producer applications or consumer applications team. Consumer applications. Developing producer applications or consumer applications using either Java or Python or Scala or any programming language which supported by Kafka. Okay. So Python, Scala or Spark or any programming language which supported by Kafka. So who are working at this side, who are working at developing producer application and developing consumer applications too. Developing consumer applications. So these are called Kafka developers. Kafka developers. So these people we can say Kafka developers. So for Kafka administrators too. Next important people, Kafka administrators. Kafka administrators team. Kafka administrators are responsible for setting Kafka cluster or set up Kafka cluster. Set up Kafka cluster. Set up Kafka cluster. Okay, set up Kafka cluster. Next one thing, monitor. Okay, troubleshoot. Performance tuning, etc. activities. So performance tuning, etc. activities. So Kafka administrator works at setting this Kafka cluster. Kafka administrators works at setting this Kafka cluster, managing this Kafka cluster, monitoring this Kafka cluster. So setting Kafka cluster, managing Kafka cluster, monitoring Kafka cluster, troubleshoot Kafka cluster, performance tuning, etc. activities. So these kind of activities like security. So lot of activities doing by Kafka administrators. Once Kafka developers develop, once they run their applications, Kafka administrators provides 24/7 environment to run that Kafka applications to run the Kafka applications. So Kafka administrators comes after application release. Yes or no? Kafka administrators are required to run Kafka applications 24/7 without fail. Performance wise, any net issues wise, Kafka administrators are important. Security wise, lot of things. Okay, so we have Kafka developers, we have Kafka administrators too. So clear writing, clear, right? Yeah. So let me copy this diagram. Okay, so clear writing, Kafka architecture. In Kafka architecture, we have four important services: zookeeper, server or broker, producer, and consumer. Okay, yep, yep. Now let's understand Kafka terminology. So we understand the Kafka architecture. Yes or no? So this is Kafka architecture. Kafka architecture. So we understand the Kafka architecture. If you observe Kafka architecture, we have some terminology: producer, zookeeper, server or broker, consumer, next one, topic, message, replica, etc. Let's understand the Kafka terminology too. So in Kafka architecture, in Kafka architecture, has some key terms, key terms like topics, producers, consumers, server or brokers, server or brokers, partitions, partitions. So first one, server or broker team. Server or broker, and producer or consumer, producer or consumer, producer, consumer, topics, partitions, partitions, messages, yeah, topics, messages, messages, partitions, partitions, replicas, replicas, leader, follower, leader, follower, okay, offset, 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 and consumer, consumer, we can say consumer, consumer application, producer application, log, log, and log, message, message, log, offset. Yep. So these are very, very important to terminology too. These are very, very important to terminology. So understanding this Kafka terminology will help us to build the strong foundation of Kafka team. So understanding Kafka terminology, Kafka terminology understanding Kafka terminology will help us to build strong foundation, strong foundation team, strong foundation, strong foundation of Kafka. Because whether you are maybe a developer, whether you may be a administrator, these concepts will help us to build a strong foundation team, strong foundation. Okay. Yep. So first one, let's understand Kafka server or broker. First, let's understand Kafka server or broker team. Kafka server or broker. Kafka server or broker. So it is the only one demand team. It is the only one demand. Only one demand. It is the only one demand runs in Apache Kafka cluster. Only one demand runs in Apache Kafka cluster. Yep. So only one daemon runs in Kafka cluster called server or broker. Daemon means background processing. Background process. Background process. It is a Scala class type. Once we run Kafka cluster, Kafka server or broker runs in the background. Kafka server or broker runs in the background team. We can take we can take one or more server or broker machines. Server or broker machines. We can take one or more servers or broker machines. If data is huge, if you need a replication factor, if you need high fault tolerant system, we go for multi-server or broker system too. Multiple servers or brokers. Okay. So we can take multiple servers or broker. Only one daemon or service runs in Apache Kafka cluster is called Kafka server or broker team. Okay. So next important topic is Kafka topic team. Kafka topic. Kafka topic. What is Kafka topic? What is Kafka topic? What is Kafka topic? So Kafka topic contains messages. Kafka maintains messages in categories team or feeds of messages in categories, and messages are stored as well as published in a category or feed name. We can call that category or feed name is topic team. In Kafka, all messages are organized into Kafka topic. In Kafka, all messages organized into Kafka topics team. Kafka topics. Simply we can say a Kafka topic hold messages. A Kafka topic holds messages. Team. Kafka topic holds messages. Kafka maintains messages in Kafka topic. Okay, so clear, right? Kafka topic holds messages. In Kafka, all messages are organized into topics. So producer can produce or write messages into Kafka topic. So Kafka maintains messages in topics. Kafka maintains messages in topics. Kafka maintains messages in topics string. Messages in topics. Clear writing? Kafka maintains messages in topics. Next important terminology, very, very important terminology. Kafka partitions team. Kafka partitions. Kafka partitions. A topic divided into multiple partitions. A topic divided into multiple partitions. A topic divided into multiple partitions. Partition is called chunk of data too. A partition is called chunk of data. A partition is called chunk of data. Chunk of data. A partition is called chunk of data. In Kafka team, we have leader and follower concepts. So Kafka, we can maintain number of partitions. We can specify a topic with number of partitions. Let's say we created a topic called C family with number of partitions of 3. So whatever the messages we are going to store, it resides in 3 partitions. It resides in 3 partitions team. So clear, right team? So a topic is divided into multiple partitions team. So next important component is called Kafka producer. Kafka producer. Next important component is called Kafka producer team. Kafka producer is an application team. It is an application. It is a application. It is an application written in any programming language. Any programming language. Kafka supports many programming languages. Kafka supports many programming languages. Many programming languages like Java, like Scala, like Python, like .NET. It supports plenty of languages too. It supports plenty of languages. Practice purpose, Kafka people given console producer team. Console producer. So Kafka producer writes messages or produces messages into Kafka topics. So once we store Kafka topic means Kafka topic divided into multiple partitions. Kafka topic divided into multiple partitions. So messages are going to store in multiple partitions too. So next important one, Kafka consumer team. Kafka consumer. So next important concept is Kafka consumer. Kafka consumer is an application written in any programming language. Kafka supports many programming languages like Java, Scala, Python, .NET, etc. Practice purpose, Kafka people given Kafka console consumer. Kafka consumer reads messages or consumes messages too. Consumes messages. Kafka consumer consumes messages too. And next, very important terminology thing. Very important terminology. Kafka offset. Kafka offset thing. Kafka offset. Very important terminology. What is Kafka offset? What is Kafka offset thing? The position of the consumer in the log. The position of the consumer in the log. And which is retained on per a consumer. and which is retained, which is retained retained on per a consumer team. On a per consumer team, per consumer basis. So position of the consumer in the log, and which is retained on a per consumer basis, per consumer basis stream. Consumer basis we call offset. So message divided into multiple offsets, message divided into multiple offsets stream. Yep. Let's understand partitions, Kafka partitions, and Kafka offsetting, Kafka partitions and offset. So producer is writing messages into different partitions too. Let's say this is partition 0, partition 0, and partition 1, partition 1, and partition 2, partition 2, and partition 3, partition 3. So we have different partitions too, different partition. So here we have different offset numbers. Offset numbers, so starts from 0 and 1, 1, 2, 3, 4, 5, 6, 7, 8, like this. In each partition we have partition numbers. Partition 2 we have 0, 1, 2, 3, 4, 5, 6. Okay. Next, coming to other partition, again we have partition numbers. Sorry, offset numbers. So 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. And other partition we have offset numbers 0, 1, 2, 3, 4, 5, 6. So we have different partitions too. Partitions and offset numbers. Offset numbers. So here producer is writing messages into partitions. So this is complete one topic. Let's say this is complete one topic. So topic name is C family. Topic name is C family. Topic name is C family, and the producer is writing messages into these partitions. We created topic C family. So topic is C family. C family. Number of partitions are partitions we created 4. So clear writing. So 4 partitions. So producer writes messages into these partitions, and these are offset numbers. Offset numbers. So flow goes to old to new team. Older messages to newer messages. Older messages to newer messages. So these are different offset numbers. Clear, right, team? Clear, right? What is partition? What is topic? What is offset numbers? Offset numbers of a message. Clear, right? Yeah. Let me copy this diagram, too. Next important terminology, Kafka consumer group. Kafka consumer group. Next important topic. Next important terminology, Kafka consumer group. Kafka consumer group. So Kafka consumer in Kafka architecture, we can take one or more consumers too. We can take one or more consumers, and some consumers we can create a group. We can create a group. Let's understand Kafka consumer. A consumer group, a consumer group, a consumer group basically represents the name of an application team. Kafka consumer group basically represents name of represents the name of an application. Name of an application. A consumer a consumer a consumer belongs to default group. Default group. A consumer belongs to default group, or we can specify consumer group name at application level, or we can specify we can specify we can specify group name in application. So while writing application, we can specify the group name. If it is a console consumer, in console consumer configuration, default test group is created team. So we can use that test group name. If you want to configure, we can configure in console consumer configuration file. Console consumer configuration file team. So every consumer belongs to a particular group. Particular group. Group nothing but a name of an application team. Name of an application. So with the consumer group, with consumer group, consumers can label themselves too. So every consumer application represents group name or name of the application with group. And next, very, very important terminology team, Kafka log. Kafka log. Kafka log. Kafka log. So Kafka log is nothing but a partition tool. Kafka log is nothing but a partition. A data source which writes messages in log. So in server or broker configuration, we will specify the log directory. We will specify the log directory. So log is nothing but it's a partition tool. Another way to view a partition. So data source writes messages into the log. So consumers reads messages from log nothing but partitions. Consumers reads messages from the log team. A log is nothing but partition team. Nothing but partition. A source writes messages to the log. So one or more consumers reads the data from the log. Reads the data from the log team. From the log. Logs will creating server or broker machine. Server or broker machine. So message logs too. Message logs creates in server or broker machine. So data source writes messages into Kafka log. Clear, right? So next in node team, next important terminology, Kafka node. Kafka node. Node means mission team. Node means mission. So node means mission. Node means mission. Node means mission. Yes, mission in cluster. Mission in Kafka cluster. Mission in Kafka cluster, we can call it as node. Next important one, Kafka cluster. Kafka cluster. Kafka cluster means collection of nodes. Collection of nodes is called Kafka cluster. Group of nodes or collection of nodes. or group of nodes team. Group of nodes or collection of nodes, we can call it as Kafka cluster. Next, very important one, very important one thing, Kafka replication team, Kafka replica, Kafka replica, Kafka replica. What is Kafka replica? See, I said a topic is divided into multiple partitions. A topic is divided into multiple partitions. Let's say team, we created one topic. We created topic is C family, partitions are 4. So your data going to write into 4 partitions. Your data going to write into 4 partitions. Okay. So let's say we have only one mission and one topic, C family topic. We are continuously writing data into this topic. Let's say this mission is down. This mission is down. What will happen? If this mission is down, we cannot access C family topic. Yes or no? So to avoid that fault, we can apply replica team. We can create multiple replicas so that the replicas are going to create in different server. Let's say this is server 1. This is server 1. Similar way, we have server 2, server 3, server 4. So replicas are 3. So 3 server missions we have: partition 1, partition 2, partition 3, partition 0, partition 1, partition 2, partition 3. We have in 3 missions. When we say replica 3, so replica means duplicate. Replica means duplicate. Replica means duplicate copy. Duplicate copy. Duplicate copy of a topic. Duplicate copy of a topic link. Simply we can say replica is a backup. We can say it is a backup. It is a backup copy. It is a backup thing. Or backup of partition. Backup or backup of partitions. Backup of partitions. It is a backup of partitions too. So why we use replica? To prevent data loss. To prevent data loss. Data loss. We use replica. We use replica. It is a backup copy of your data. Okay. So next important one team. Next important terminology. Next important terminology team. Kafka message. Kafka message. So main important one, Kafka message. So message in Kafka is information which travels from the producer to consumer through the Kafka. Message is a information. Message is a information. Message is a information travels from producer to consumer through Kafka. Simply producer writes messages into Kafka topic and consumer consumes messages from Kafka topic team. And next very important one, Kafka leader team. Next very important terminology, Kafka, Kafka leader, Kafka leader. Kafka leader team. What is Kafka leader? What is Kafka leader team? So here we have 4 partitions team. We have 4 partitions. Okay. So here we have 4 partitions. Let's say team, let's say team, we have 4 partitions. We have 4 partitions team. We have 4 partitions. For this partition, let's say replica 3 replicas or 2 replicas. Replica is 2. This partition we have follower, leader, and this partition is a follower. This partition is a follower. For one partition, this is a follower. Okay. Here, for this partition, it is a follower, and for this partition, it is a leader. It is a leader. For this partition, let's say this is a follower, this is a leader. This is a leader. For this partition, this is a leader, and this is a follower team. This is a follower. Let's say user is consumer is reading. Let's say consumer is started reading. Consumer application trying to read data team. Consumer application trying to read the data from partition 0. So who is leader? Partition 0 of mission 1. Let's say this is node 1. Node 1. This is node 2. This is node 2. So consumer is reading partition 0. So first it will try to read data from this partition 2. Assume this is not available. Then immediately this partition, this one become, this follower become leader. Our consumer reads message from this partition thing, node to partition 0. Node to partition 0 thing. So understand, right? There is no server, there is no slave, worker and slave concept. Here we have a concept called leader and follower. So the node which is responsible, the node which is responsible for all reads and writes, for the given partition, given partition is called leader thing, is called Kafka leader. So every leader consists of one server. Every leader consists of one server team, one server or broker. Next, coming to Kafka follower team. Kafka follower. Kafka follower team. Now let's understand Kafka follower. Who is Kafka follower? A node that follows a node that follows leader instructions. Leader instructions. Leader instructions is called Kafka follower. A node which follows leader instructions is called Kafka follower. If any leader fails, if any leader fails, if any leader fails, any of the follower, any of the follower become leader team. Any of the follower become leader automatically. Here also our zookeeper plays important role team. Which follower to become a leader? We have, let's say, replica 3. We have one leader, 2 followers. One leader, 2 followers. One leader is down. Any of 2 followers, not 2 followers, any of 1 follower may become a leader. Okay, so clear writing. Clear, right? Next, very important one, data log thing. Data log, Kafka data log. Next important one, Kafka data log. Kafka data log. What is Kafka data log? What is Kafka data log? So Kafka data log, nothing but it's a messages are preserved through the Kafka for some amount of time. Messages are preserved. Messages are preserved some amount of time. Some amount of time. Some amount of time. Okay, some amount of time. Some amount of time through the Kafka. Through the Kafka team. By default, every message resides 7 days team. Every message resides to 7 days. We can configure team. We can configure team. So Kafka consumer can read as per their convenience. It is not mandatory. Once producer writes message, consumer has to read. It is not mandatory. Consumer has to read once producer completed writing messages. Consumer can read at any point of its convenient time. So consumer can read message. Consumer can read message at any point of time. At any point of time, consumer can read message at any point of time at their convenient time. at their convenient time too. It is not mandatory to read message immediately once producer writes messages. Consumer can read message at any point of its convenient time. Its convenient time too. Okay. So next important one, very important one thing, Kafka API. Kafka API too. This is very important. Kafka API is very important. API stands for Application Programming Interface. API stands for Application Programming Interface. Application Programming Interface. Kafka people given API for different languages. API for different languages. Different languages like Java, Scala, Python, many languages too. API contains predefined classes, functions to connect Kafka and write messages and read messages, and read messages too. So Kafka API contains predefined classes to connect to Kafka, to write messages into Kafka topic, to read messages from Kafka topic. Kafka people given API for different languages, Java, Scala, Python, etc. So these are very important Kafka terminology. These are very important Kafka terminology. Okay. Yeah. So clear writing. Let's start in Kafka installation on single node on Windows operating system. Okay, first let's understand Kafka installation introduction. We already discussed Kafka is free and open source. Kafka is free and open source, and Apache is vendor of Kafka. Apache is vendor of Kafka. Kafka software is implemented using Scala language. To run any Scala softwares, any Scala software, we require JVM, Java Virtual Machine Team. Java Virtual Machine Team. So now let's understand steps to install Kafka. Steps to install Kafka. Steps to install Kafka team. First step one. Java must be installed team. Java should be installed. We already understand Kafka is implemented using Scala language. Scala runs on JVM. So any software which developed based on Scala runs on JVM. So JVM is part of Java. So Java should be installed. Recommended is recommended recommended is Java 8. Recommended is Java 8. Next one, step 2. Step 2, install Kafka software. Install Kafka software. Install Kafka software team. Next one team, step 3. Step 3 team. Step 3, configure Kafka. Configure Kafka. So step 1, install Java. Recommended Java version is Java 8. And after installing Java, I recommend to install Kafka latest version. After installing Kafka, we have to configure things. We have to configure Zookeeper. We have to configure Kafka server or broker. We have to configure console producer. We have to configure console consumer. To work with the console producer and console consumer, we have to configure. Okay. So after installation, we have to perform configuration too. So installation, Kafka installation, we perform 3 steps. And next one, verify Kafka is installed or not. Step 4. Step 4, verify Kafka is installed or not. Kafka is installed or not. So total 4 steps we perform as part of Kafka installation on Windows operating system. So these are 4 important steps. Yeah. Let's start it. As part of languages installation on Windows operating system, let's see Java installation on Windows operating system too. Let's see steps to install Java 8 on Windows operating system. Windows operating system too. Steps to install Java 8 on Windows operating system. So many third-party softwares supporting Java 8 team. The procedure of installation of Java is same for all versions. At this point of time, many softwares which developed based on Java supporting Java 8. Okay, so that's why in this session I am explaining Java 8 installation team. The procedure of Java installation is same for all Java versions. First step 1 team. Step 1, download Java 8. Download Java 8 and or Java 1.8. Second one, step 2. Step 2, install Java 8. Install Java 8. Next step 3. Step 3, set Java underscore home and path variable. Set Java underscore home, path variable. Next one, step 4. Step 4. Verify Java is installed or not. Java is installed or not. So these are 4 important steps we are going to perform as part of Java installation team. First, let's see Java installation. Download Java. Let's see team. Download Java team. Download Java. Okay. So open any web browser. Open any web browser. Search Java 8 download. Java 8 download. This is the first link team. This is the first link. Java 8 download. Okay. So this is the first link. Yeah. So here, if you observe, it is showing different operating system supported Java versions, Linux supported, okay, and Mac operating system supported, Apple Mac operating system supported, Unix operating system supported, and Windows operating system supported. In Windows, again, we are seeing Windows x86, it is 32-bit supported. Windows x64, it is 64-bit supported. Click on this one. Click on this one. Accept license agreement. Click on download. When you click on download, it will open this page, login page. Once you click on this download, it will open login page. Here you have to enter your login credentials team. Login is create, if you do not have a account in Oracle, create account, it is free, and click on sign in. Then it will start a downloading team. Once you enter that download option, it will take you to login page. Then click on sign in page. It will verify your account. Then start downloading team. It will start a downloading. Okay, let's wait team. Once you successfully signed in, it will ask us to download. I'm downloading my all softwares languages in languages folder. Click on save button. Start downloading. Start download. So download is completed. Download is completed. Let me see. This is my downloads folder. Languages. So download is successful. Once it is downloaded, now let's install Java 8. Install Java 8. Install Java 8. Installation is very easy team. Installation is very easy. Double click on downloaded file. Double click on downloaded file. Downloaded file. And choose all default options. Choose all default options. Choose all default options. So let's go download location. Double click on this exe file. Click on yes button. Click on yes button. Yeah, here it is started team. Click on next button. Then it is by default it is going to install in under C program files, Java, JDK folder team. So click on next button. Click on next button and it started installing. Yeah, click on next button. It is installing JRE. Click on next button. So we are installing Java 8 update 301. Yeah, let's wait a few minutes, team. Yeah, installation is successful, team. Click on close button. Now Java 8 is successfully installed. Now let's understand set Java underscore home path variable. Next important step is set Java underscore home and path variable team. Set Java underscore home path variable. First, why we need to set Java underscore home. Why we need to set Java underscore home? There are many softwares. There are many softwares implemented using Java team. There are many softwares implemented using Java language like like Maven, Hadoop, Scala, Kafka, plenty of softwares implemented using Java. All these softwares, all these softwares, all these softwares requires, all these softwares requires Java to run that software, to run that softwares, to run that softwares, they require Java team. They, they, they refer, they refer or they refer Java underscore home to find Java path team, to find Java path. Okay, so that's why we are setting Java underscore home. All third-party softwares which are implemented using Java uses Java underscore home to run that software team. Okay, so we set Java underscore home. We set Java underscore home before bin path team. Let me show. In C drive, we have program files x86. If any 32-bit software, if you install, it is installed in program files. 64-bit software is installed in program files. We have installed 64-bit, right? So click on this program files. Here we have Java. Under Java, we have JDK, JRE. We have to set JDK. So this is the bin path team. So before bin path, we have to set Java underscore home before bin path team, before bin path. Next one, why we need to set, why we need to set, we need to set path variable. Why we need to set path variable? Why we need to set Java underscore home? Why we need to set path variable team? Why we need to set path variable? If you observe in bin directory, we have different Java commands. Java command, jar command, Java C command, Java P command. There are various Java commands too. So in Java underscore home, in Java underscore home slash bin, Java underscore home slash bin has Java commands, has Java commands or Java binaries. Java binaries. To make to make to make Java commands available anywhere in our system. Anywhere in our system. Anywhere in our system, we are setting Java path variable thing. Path variable. Okay. So path variable we set until bin directory thing. Until bin directory. Path variable we set until bin directory thing. Okay. Now let's set. How to set? Click on this PC. In Windows 10 operating system, click on this PC, right click on this space, click on properties. Here you see advanced system settings. Here you see environment variable. Here we see user variables, system variables. User variables only for this currently logged in user. System variables are for any user presented in this operating system team. We may have one user, we may have 10 users, we may have 50 users. For all users, if you want to set Java available, then set system underscore variables. Click on new button, type Java underscore home. Java underscore home team. Variable name equal to Java underscore home. Variable value equal to until this path team. Until this path. Click on OK. So we set Java underscore home successfully. Now let's set path variable. Path variable already presented team. Select path variable. Click on edit button. Click on edit button. Here click on new button. You can enter complete path like this. You can enter complete path like this, or you can use percentage Java underscore home, %/bin. This approach is recommended. This approach is recommended. Why this approach is recommended? Because in our system currently we have Java 8. Later we may install Java 9, Java 10, Java 11, Java 12, etc. Yes or no? So instead of changing this path multiple times, just change in Java underscore home. That will reflect all the places wherever we are referring. Okay. So this approach is recommended. Click on OK. Click on OK. Click on OK. So we successfully set Java underscore home and path variable thing. Now let's verify. Java is installed or not. Now let's verify Java is installed or not. Now let's verify Java is installed or not. Open command prompt. Type Java space -version or type JavaC command, Java command, or type JavaC command. If you are seeing options means, then we can say Java is successfully installed our machine. Let me close this properties. Now let's open command prompt. Type Java space -version, Java space version. So Java version, it is showing 1.8.0_301. So we install the same version. Type Java command, JavaC command. Go to F drive. Now type Java command, JavaC command. So commands are working anywhere in our system. Now we can say Java is successfully installed. Java commands are working anywhere in our system. Clear, right, team? How to install Java in Windows operating system? Clear, right? So we have successfully installed Java in Windows operating system. Okay. Yeah. Yep. Now let's see step 2, Kafka installation team. Step 2, Kafka installation. So we already seen Java installation. Now let's see steps to install Kafka. Steps to install Kafka team. Steps to install Kafka on Windows operating system. Steps to install Kafka on Windows operating system. Step 1 team. Step 1. Step 1. Download Kafka. Download Kafka software. Download Kafka latest version team. Okay. Download Kafka latest version. Step 2. Step 2. Install Kafka. Install Kafka. Step 3. Step 3. Set one. Set Kafka underscore home. Kafka underscore home and path variable. Path variable thing. Set Kafka underscore home path variable. Set Kafka underscore home path variable. Okay. And after doing these 3 steps, next step 3, we are going to install Kafka. Okay. So let's download Kafka team. Download Kafka latest version. Download Kafka latest version team. Let's open any web browser team. Let's open any web browser. Here, search Apache mirrors. Click on this first link team. Click on this first link. Here, we can see Kafka. Click on this Kafka. Here, Kafka latest version is 2.8.0. 2.8.0. Here we see TZZ file, Kafka TZZ file. Click on this. This is the latest version. At this point of time, this is the latest version. At this point of time, this 2.8.0 is latest version. Click on this TZZ file. It will start downloading too. Let's wait to downloading. After download successful, we will install Kafka. We will install Kafka too. After successfully download, we will install Kafka. Yep. Let's wait few minutes team. Depends upon your internet speed. It may take few minutes time to download. It is around 68 MB. Yeah, download is successful team. I'm keeping all softwares under F drive, C family, software. Here, streaming, I created one folder, streaming team. Okay. So I'm placing all my downloaded softwares in F drive, C family, software team. Under streaming, I am placing this one. Now let's install Kafka software team. Installation means extracting extracting tar file, rename extracted file, remove tar file. That's it. These two are optional thing. Optional. These two are optional. Okay. So rename extracted file, remove tar file is optional. Extraction nothing but installing Kafka. Use 7-zip or WinRAR or any unzip software. Use any unzip software too. Unzip software. Okay. So let me go to download location. Right click on this one. Here I'm using extract here. You can use 7-zip extract here. Sorry team. So if you use 7-zip from tar file, tgz file, we get tar file. From tar file, once again we have to use extract here. Then we will get folder team. If we use WinRAR extract here, it will directly extract a folder from tar file. Once extracted, let's see team, it is lengthy. Kafka underscore 2.13-2.8.0. Optionally, remove this tgz file. Optionally, rename this lengthy name to short name. Sorry. Right click on this one. Rename with the short name team. Instead of this lengthy name, remove it lengthy name to short name team. So that's it for installation of Kafka. So that's why we are going to perform one more important step called configuring Kafka. Okay, installation is successful team. Now let's set Kafka underscore home and path variable team. Next important one, set Kafka underscore home path variable. Kafka underscore home and path variable team. Set Kafka underscore home and path variable. So Kafka underscore home and path variable. Let's understand team why we are setting Kafka underscore home and path variable. Why we are setting Kafka Kafka underscore home and path variable. Kafka underscore home and path variable too. Why we are setting Kafka underscore home and path variable? If you go to installation path, so we set Kafka underscore home up to this part thing before bin path. Kafka underscore home we set before bin path, and path variable we set up to bin path. Let's go here. Go to bin path. Under bin, again we are seeing Windows. Under Windows we are seeing all Kafka commands. All Kafka commands. Let's observe. First one, zookeeper command. Zookeeper start. Zookeeper hyphen server hyphen start. Zookeeper hyphen server hyphen stop. Next one, Kafka hyphen server hyphen start. Kafka hyphen server hyphen stop. Kafka hyphen producer console producer. Let's see. Kafka hyphen console hyphen producer to start producer application. To start console consumer application, we have Kafka hyphen console hyphen consumer. To create topics. Let's see. Kafka hyphen topics. This command can be used to create topics. All these commands are presented in under Kafka underscore home /bin /Windows to make all these commands. To make all Kafka commands available anywhere in system. We set Kafka underscore home and Kafka underscore home and path variable thing. Let me set Kafka underscore home. First, let's copy this path team. Click on this PC. Right click here. Click on properties. Here, advanced system settings, environment variable. Here we have user variable, system variable. User variables only for this currently logged in user. System variables are for any user in the system. Click on new, type Kafka underscore home. Kafka underscore home, place this value before bin path to. Click on OK. Next one, path variable is already available. So select path variable, click on edit. Click on new, write this complete path. This is one way, but recommended is percentage Kafka underscore home percentage /bin /Windows /bin /Windows 2. Now we can set in this way. Why we are using percentage Kafka underscore home percentage? In our system, we may have multiple versions of Kafka. Whatever the version we configured in Kafka home, that is available for all the locations wherever we are referring Kafka. So instead of changing in all the reference locations manually, we use this approach for referring Kafka current to using Kafka team. Okay. So click on OK. Click on OK. Click on OK. Close this properties. Then we can say Kafka home and path variable is successfully available. So now verify Kafka is installed or not. Verify Kafka is installed or not. This fourth step I am doing here. Verify Kafka is installed or not. Before executing third step, I am executing fourth step team. I am executing fourth step because we already set Kafka underscore home and path variable. Execute any of Kafka commands team. Execute any Kafka command if it shows options. If it shows options, then we can confirm Kafka is installed in our machine. Okay, so let's open command prompt. So let's see under F drive, under C family, under software, under streaming, under Kafka, under bin, under Windows, we have different commands. Yes or no? Let's say Kafka-server dot start. Yes or no? So let me open command prompt. I installed Kafka in F drive. I am running Kafka command in C drive. Kafka server start. Just type this command. So it is saying uses Kafka server requires server dot properties. Okay. Kafka let me execute another command in. Let's say another command. See Kafka topics. Kafka topics. Yes. Are you observing some options? It means Kafka is installed, configured successfully. You can execute any of this command, it will work too. Next, let's see checking Kafka version team. Checking Kafka version. Kafka topics version. So we installed Kafka 2.8.0, right? So then we can confirm Kafka is installed successfully. Kafka is installed successfully. Okay. So that's it for verifying Kafka team. Verifying Kafka is installed or not. Clear, right? Yeah. Once we install Kafka, we have to perform Kafka configuration. In configuration, we will specify zookeeper details, server or broker. We will configure we will configure zookeeper server or broker, optionally console producer and console consumer and console producer we will configure optionally. Okay, so first let's see zookeeper configuration team. Zookeeper, and one more important point team, all configuration files all configuration files all configuration files all configuration files present present in present in kafka underscore home slash, let me see, kafka underscore home means this one thing. Here we see config kafka underscore home slash config. Here we see all configuration files all configuration files all configuration files team. Now let's see zookeeper configuration. zookeeper configuration zookeeper configuration zookeeper configuration. So there is one file called zookeeper.properties file. Zookeeper.properties file. Okay, so let's open this zookeeper.properties file. Zookeeper.properties file. Here if you observe, first data directory, we have to specify data directory team. We have to specify data directory. So data directory, I am creating data directory under Kafka. Here I am creating data directory. Under data directory, I am creating zookeeper. So this is my data directory path team. So change this zookeeper directory path. Okay, let's copy this one. So this is very important. First important change in zookeeper file is we will configure where we want to store zookeeper related data and default port. This is the default port. Next one team, 2181 is a default port. 2181 is a default port of zookeeper team. Default port of zookeeper. Okay, main change we do is this one thing. So we successfully changed zookeeper. Next one team, server or broker configuration. Server or broker configuration team. Server or broker configuration. So there is one file called servers. Let's go Kafka. Let's go config. Here we see server.properties file. So server.properties file too. Server.properties file. Server.properties file. In server.properties file, we will configure server details too. So let me go to Notepad. So first important one thing, port equal to here 9092. So first important one thing, every server or broker contain unique ID. Every server server or broker has unique ID. Unique ID. So ID we start at 0. Next one, Kafka server or broker. Kafka server or broker runs on default port is 9092 team. Default port is 9092. Next one, next important one team, data directory. Logs directory team. Logs directory. Next important one, logs directory. Here I am going to create a log directory under Kafka, under data directory. Here I am creating server. So let me copy this one. So this is the log directory path to. This is log directory path. Log directory path. So we are going to change this log directory path. Next one, next important to change is zookeeper server details too. Zookeeper server details. Next important to change is zookeeper server details too. So these are the main changes we perform as part of server configuration too. Next one, yeah, next one, optionally configure. Next one, optionally configure console console producer and console consumer. Optionally configure console producer and console consumer. Console producer and consumer console consumer, they given for practice purpose team. Practice purpose team. They given practice purpose. Let me configure console producer. Let me configure console producer team. So here we see one configuration file. Go to Kafka, go to configure. Here we see producer.properties file. Producer.properties file. Producer.properties file. Producer.properties file. In producer.properties file, we will specify server details, server or broker details. Producer.properties file. Already it is configured team. Already it is configured. Okay. So if we have multiple if we have multiple server or brokers, then this file configured in this way too. IP colon server1 underscore IP colon comma server2 IP colon comma and so on server n IP. So in this way, comma separation, we will provide our server details called bootstrap.servers. So in this way, we will configure multiple server details in console producer and console consumer. So similar way, console consumer also same thing. Console consumer. Here we have consumer.properties. If it is a single server, we specify like this. If we have multiple servers, we specify in this way too. Currently, no need to change anything because we have only one server or broker. And both console producer, console consumer, and server or broker running in same mission. That's why we are using localhost. Let me open consumer.properties file. Let me open consumer.properties file in this way too. So in consumer, additionally we give group name. Here I am giving C family. In consumer, we give consumer group team. So additionally we give one more important one in consumer file, group ID. Group ID I am giving C family. So that's it for console consumer and console producer configuration. That's it for configuration of Kafka or Kafka configuration thing. With this, we can say Kafka installation is completed. Kafka installation is completed. So we have installed Java, we have installed Kafka, we have configured Kafka, we already verified Kafka is installed or not. Then we can say Kafka installation is successful on Windows operating system. Okay. Yeah. Next important one, Kafka console producer and Kafka console consumer. Kafka console consumer team. Practice purpose. Practice purpose. Kafka people given. Kafka people given. Kafka console producer and Kafka console consumer. Kafka console consumer team. Practice purpose, Kafka people given, Kafka console producer and Kafka console consumer. Kafka console producer and Kafka console consumer. Kafka console consumer is a predefined applications. Is a predefined applications. Predefined applications. Okay. So now let's implement messaging system team. Example, write messages using Kafka console producer, and consume messages using Kafka console consumer. So this is our requirement team. Write messages and read messages. Okay. So for this one team, for this one, step one, step one, start zookeeper team. First, start zookeeper. Start zookeeper. Start zookeeper. Step one, start zookeeper. Start zookeeper. Open command prompt. Open command prompt and start zookeeper team. Let me see here in our Kafka foundation. Here I'm creating one workspace. Or let's say here we have workspace. Let me streaming. Under streaming, I'm creating Kafka workspace. Okay, let me open command prompt here. You can start command prompt anywhere too. Here I'm starting Kafka hyphen, sorry, zookeeper hyphen server hyphen start. First one team, syntax, in command prompt we use zookeeper hyphen server hyphen start and zookeeper property file. Zookeeper properties file. Zookeeper properties file tip. Yeah, let's see example team. So I'm starting zookeeper hyphen server hyphen start and path of zookeeper is let me open F drive. Under F drive, C family. Under C family, software. Under software, streaming. Under streaming, Kafka. Under Kafka, we have config. Here we have a configuration file. In this, we have zookeeper.properties file. Okay. So we have to use this command too. We have to use this command. Press enter. So it is started zookeeper. It is starting zookeeper team. Let's wait. So this is my zookeeper. So zookeeper is started successfully. Zookeeper is started successfully. Now let's start server or broker team. Next one, let's start server or broker. Start server or broker. Step 2 is start server or broker team. Okay, so here Kafka hyphen server hyphen start server properties file. Server properties file team. Here we use Kafka hyphen server-start, and we pass server properties file, server.properties file team to start Kafka server or broker. Let me open command prompt. Let's type Kafka-server-start and server.properties file location. It is starting Kafka server. It is trying to connect with Zookeeper. So ID is 0, broker ID is 0, and port number is 9092. So Kafka server is successfully started. Kafka server is started successfully. Next to step 3. Step 3. Step 3. Create a topic team. We started Zookeeper successfully. We started server or broker successfully. Now let's start Zookeeper. Sorry, create a topic. Create a topic. Kafka topic. Kafka topic team. So here we are going to perform some operations team. First, let's see step creating Kafka topic. Create a Kafka topic. List Kafka topic. List Kafka topics. List Kafka topics. Describe particular topic. Particular topic team. Describe particular topic. Describe particular topic. So these are the steps we are going to perform as part of Kafka team. First, let's see create Kafka topic. Create Kafka topic. So create a Kafka topic. Okay. So create Kafka topic. List Kafka topics. Describe Kafka topic. Okay. First, let's see topic creation. Yeah, let's see team. Kafka topics create topic, topic name, number of partitions, replication factor, and Zookeeper address team. Zookeeper address. So Zookeeper is running in local machine. Yes or no? Let me open new new command prompt. So we have Kafka Zookeeper. We have server or broker. We have server or broker. We have server or broker team. Next one, let's create a topic. So I'm executing topic creation logic. I'm executing topic creation logic. So Kafka topics create topic. Topic name is C family. Partitions, 3 partitions. Replication factor 1. Zookeeper details. So topic is created successfully. Once we see here, it is showing topic is created successfully. So topic is created successfully. Topic is created successfully. Okay. So here, important to note, important to note. Note. Replication factor is less than or equal to number of servers or brokers team. Number of servers or brokers. Here we have how many missions? Only one mission. So replication factor always less than or equal to number of missions team. So here replication factor we set 1 because we have only one server or broker. We have only one server or broker. That's why we specified only one replication factor team. Okay. So next one, partitions, we specified 3. We created topic name is C family. So now let's list topics setting. Let's list topics. To list topics, we use Kafka topics zookeeper and zookeeper IP address hyphen list team list team. Let me copy this command. Let me execute. Kafka topics zookeeper team zookeeper IP address port number list. So only one topic is available. Yes or no? Only one topic is available. Only one topic is available. Next one, describe the topic. Describe the topic team. Describe the topic. Next important one, describe topic team. So we use Kafka topics command, topics command, and zookeeper zookeeper host name describe topic name. Okay, so this gives who is leader of the topic and which missions are followers of that topic, and it gives replication factor details, leader, followers, replication, and in sync replica concept. So let me execute this command zookeeper describe and topic name team. Let me execute this command team. Kafka topics zookeeper localhost : 2181 describe topic name. Let's observe. So here topic name is C family. Topic name is C family. Topic ID Next one, number of partitions are 3. Replication factor is 1. Partition 0, leader 0. Partition 1, leader 0. Partition 3, leader 0. There is no followers. We have only leaders because we have only one server or broker. Yes or no? So clear writing. So we have created topic, we have list topic, and we have described topic. Yes or no? Now let's send messages to send messages. Now let's send messages to 1 minute. Yeah. Now let's send messages. To send messages, we use console producer. To send messages, to send messages, we will use console producer. Console producer. Yeah. To send messages, we use console producer. Console producer is a predefined application thing. Console producer is a predefined application. Predefined application. So by using console producer, we can send messages to topic team. We can send messages to topic, or we can write messages into topic. We use console producer hyphen broker and broker IP address. If we have multiple brokers, brokers list we specify by separating list of comma. Okay. Next one, hyphen topic name thing. Then we use Kafka console producer hyphen broker hyphen list, broker list hyphen topic hyphen topic name thing. Hyphen topic name thing. So we have server, we have topic created, right? Now let's see console producer thing. Let me open console producer. Let me open console producer. Yep. So let me use this command to produce messages string. So let me use this command. So here I am executing command Kafka console producer broker list localhost colon 9092 topic name. So it will start producer and waits for writing messages. I am writing message to welcome to Kafka world. Welcome to Kafka world. So it is waiting for another message. Welcome to C family. C family is a self-paced training portal. Self-paced training portal. So I written some messages. Who is going to consume these messages? Consumer. Yes or no? Consumer is going to consume these messages. Consumer is going to consume these messages. Yes or no? So we successfully write messages. Now let's see console producer, sir, consumer. So consume messages to consume messages. Consume messages team to read or consume, to read or consume messages, to read or consume messages, to read or consume messages. We will use console console consumer, console consumer team. Console consumer is a predefined application. Console consumer is a predefined application. Predefined application. Console consumer is a predefined application. Yeah. To read whole messages, we use Kafka console consumer bootstrap server, and IP address. You can use localhost or 127.0.0.1, or you can use localhost or IP address of your machine. Bootstrap or IP address :9092 topic name from beginning. Okay, it will read messages from beginning team. It will read messages from beginning. So let me open one more terminal. CMD. Let me open this terminal. Let me run this command team. Let me press enter. So it is send a request to server, and it is received messages from the beginning. Whatever the messages presented in topic, we have received successfully. Let's try here. Hello consumer. You will get message in consumer side. How are you? So here we are writing messages. Consumer is continuously consuming messages. Clear, right team? How to implement a console consumer and producer application? So first we will start a zookeeper. Next we will start a server or broker. Next we will create a topic. Next we will write messages in topic. We will write messages in topic. Then we will consume that messages team. We will consume that messages. Okay. Clear, right? Okay. Yeah. Now let's see Kafka multi-node cluster setup on single machine on Windows operating system. Let me diagrammatically discuss it. So currently we have this is our Windows operating system. Windows operating system, right? So we have Windows operating system. Yeah, in this Windows operating system, we started Zookeeper. And we started one server or broker. We started one server or broker mission team. So first one, Zookeeper. zookeeper. Next one, server one we created. Server one we created, and we are using console producer. Console producer, we are using console consumer. Yes or no? We are using console consumer. Console producer, console producer, and console consumer. Console consumer, console producer, and console consumer too. I want to create a multiple server or broker machines in this same mission team. I want to create multiple server or broker machines. So like this, I want to create multiple servers or broker machines. So server 2, server 2, server 3, server 3. Okay. So I want to create multiple servers or brokers in a same mission. Same mission, I want to create multiple servers or brokers. So here, to perform this activity, we will create multiple server or broker properties file team. To create this implementation, team, to create multiple servers or brokers, to create multiple servers or brokers in same mission. We will create separate server properties file, server dot properties file, server dot properties file team. Server 1, for server 1, let's say server 1, we are using server dot properties, server dot properties. Okay. So like this, I want to create 3 servers: server 1, server 2, server 3. So server 3 dot properties for server 3, server 2 dot properties for server 2. Okay. So now let's configure team. Configure first one, configuration team. Configure multiple servers. Configure multiple servers. Configure multiple servers. So let me open configuration directory. Here we have server 1, right? Similar way, let's open this one. Let's save this one as server 2 dot properties. Server 2 dot properties. Let's create one more, save as server 3 dot properties. Server 3 dot properties. Okay. So first step here, create server 2 and server 3 properties file. Server 3 properties files. Server 2 and server 3 properties files. Next to configure server 2 and server 3 property files from server 1 properties file. From server 1 properties file, create a server 2, server 3 properties file. Configure server 2 and server 3. Server 3, configure server 2 and server 3 too. Okay, so let me open server 2 and server 3. Let's go config, open server 2. Let's open server 3. Server 3 dot properties file. Okay, server 2 dot properties and server 3 dot properties. In server 2 dot properties, I am giving broker ID 1 and port number is 9093. Server 2 dot properties file. Server 2 dot properties. Okay, next important one team. Data directory path 2. Data directory path. So here server 2, I am creating logs directory path. Logs directory path. Along with this modification, create logs directory path 2. Go to Kafka, go to data directory. Let me create server 2 folder. Server 2, and let's create a server 3. Let's create one more server 3. Server 3. Okay. So we created folders too. So before that, create log folders for server 2 and server 3. Create log folders for server 2 and server 3. Sorry team. So we have created server 2. So we created server 3. Then we are configuring that details in server.properties file. So we created server2.properties file. Similar way, let's change to server 3. Server 3 broker ID is 2. Port number is 9094. And this logs directory is 3. Let's open server 2, save this one. Go to server 3. Port number is 2 and 9094. 9094. And next one, data directory. Logs data directory server 3. Let's save this one too. So these are the changes we are going to do as part of server and broker team. Clear, right? Clear, right? Next one team. Next one. This is server 3. Server 3 dot properties. This is server 2 dot properties. Next one thing, configure configure console producer and console consumer. Configure console producer and console consumer team. So let me configure console producer team. Configure console producer. So open console producer. Open console producer dot properties. So here producer dot properties. Producer dot properties. In producer dot properties team, we will configure about mainly these server details team with comma separation, comma 9093, comma 9094. This is the main entry we configure Zookeeper server details team. Zookeeper server details. Similar way, console consumer team. Console consumer. In console consumer also, consumer.properties file, consumer.properties file, we will change only this one thing. Let me open consumer.properties file, consumer.properties file. Okay, let's change this one thing. That's it. Remaining is same. So configuration is completed. Configuration is completed. Now we can say we have one Zookeeper and 3 servers, one console producer, one console consumer. So we successfully installed multiple servers in same machine. Okay, clear, right? Yeah. Now let's see console producer and console consumer on multi-node cluster team. The main advantage team, the main advantage of multi-node cluster is if any server are broken down, still we can access messages from topics. Okay, still we can access messages from topics team. First one team, step one, start Zookeeper. Okay, so we have already Zookeeper running. Let me stop old one. So to start Zookeeper, we use this command team. Start Zookeeper. This is the command we use. So Zookeeper we started successfully. Now let's start step 2. Step 2 team. Start server 1. Start server 1. Start server 1 team. So this is server 1 logic. This is server 1 logic team. To start server 1, we use this command. Okay. Next to start server 2 team. Start server 2. Step 3. Start server 2. Here we use properties file 2 team. Properties file 2. Command name is same, but different properties file. So let me use starting server 2 team. Already we started server 1. Let's start server 2. Copy this one. Let me export this server 2. Press enter. It is starting server 2 team. Let's wait. It is starting server 2. So server 2 is started. Kafka server ID is 1. Yes or no? Now let's start server 3 team. Let's start server 3. Let's start server 3. Step 4. Let's start server 3. Only property file name we will change. Server 3 dot properties. Let me open another window. Here. Let me execute this command team. Let me copy this command. Let me execute this command. Now we can click on enter. It will start server 3. So server 3 also started team. Server 1 started, server 2 started, server 3 started. Now let's create a topic team. Create a topic. Step 5. Create a topic. Create a topic. Okay. Let's create a topic team. So here we have one more mission. This way. Here I am creating topic. Let me create a topic. Topic name is big data. Topic name is big data. Number of partitions are 3. Replication factor also 3. This time I am giving replication factor 3. Previously replication factor is 1. Let's describe this topic team. Let's describe this topic. You will clearly understand. Create topic. Now let's describe topic team. Describe topic. So let me execute describe command. Yeah. Topic name is big data. Big data. Kafka hyphen topics hyphen zookeeper. Zookeeper hostname. Describe big data. Observe this describe thing. Describe output. Press enter. So if you observe, partition 0, leader is mission 2, remaining all are followers. So replicas is 2, 0, 1. In sync replica. In sync replica, we see followers 0, 1. Next, partition 1, leader is 0, remaining all followers. Partition 2, leader is mission 1. Clear, right? Yeah. In multi-node cluster, we have one leader and multiple followers. One leader and multiple followers still. That is the main advantage. So we created topic successfully. Now step 5. Step 6. Now step 6 it is. Step 6. Write messages. Write messages or produce messages. Produce messages. Produce messages. Produce messages too. So let me open producer, control C, cancel previous topic. So clear the screen. Let me, topic name is big data. Topic name is big data. So it is waiting for writing messages team. It is waiting for writing messages. So let me write messages team. It is multi-node cluster. Multi-node cluster. It is multi-node cluster. The next step, write messages team. Next, consume messages. Step 7. Step 7. Consume messages. Consume messages. So let me use consumer. Let me use consumer. Control C. Yes, I want to cancel. Let's see consumer team. So I want to consume messages. Topic name is big data. Topic name is big data. Let's consume messages team. So it is consumed messages successfully. It is consumed messages successfully. Now let's understand the importance of server or broker team. I'm stopping one server team. I'm stopping one server. Let me stop one server. Let me write a message. Hi, I stopped one server. I stopped one server. Hello. I'm stopping another server. I'm stopping another server also too. See, still you are receiving messages. Even if you stop message also, welcome, welcome, hi, hello. Still you are going to get message. Even if one server down also, we can receive, we can write messages, we can receive messages. It is not possible in single node. Yes or no? We can see high availability in multi-node cluster. So understand, right, team? Understand, right? Yeah. So that's it for console producer and console consumer implementation on multi-node cluster. Okay.